Welcome to the DIY Honda Garage channel. Welcome to the Diagnostic Troubleshooting Guide for DTC P1549, which indicates a high voltage in the charging system of the Honda CR-V 2023 and newer models. This issue is primarily related to the vehicle's alternator, which is crucial for converting mechanical energy into electrical energy to charge the battery and power the electrical systems while the engine is running. Identifying this DTC is critical as it signifies that the alternator is generating voltage levels that exceed the manufacturer's specified threshold. This abnormal voltage can lead to various electrical malfunctions and potentially harm onboard electronic components. Therefore, understanding the implications of a high voltage condition is vital for maintaining vehicle performance and electrical system integrity. As we move through this guide, we will outline the symptoms, causes, and a systematic troubleshooting process to effectively resolve this DTC and ensure your vehicle runs smoothly. DTC P1549 indicates that the charging system is producing excessive voltage beyond acceptable limits, leading to potential risks such as battery overheating or damage to the vehicle's electrical components. The primary component affected in this scenario is the alternator, which is responsible for generating the electrical power necessary to recharge the battery and run the vehicle's electrical systems. The alternator is usually located near the front of the engine compartment, connected via drive belts. The Powertrain Control Module, PCM, monitors the voltage output from the alternator. If the detected voltage exceeds specified thresholds, the PCM identifies this as an abnormal condition and stores the DTC P1549. This is a safety measure to alert the technician about the potential danger posed by the high voltage condition, allowing for prompt diagnosis and remediation to prevent further complications. Several potential causes can lead to DTC P1549. One of the primary causes is a faulty alternator, which can regenerate high voltage readings due to internal failures or wear. If the alternator's voltage regulator is defective, it may fail to maintain voltage levels within the necessary range. Additionally, wiring issues such as shorts, opens, or corrosion could contribute to incorrect voltage readings being sent to the PCM, thereby triggering the DTC. Another possibility is a glitch or malfunction within the PCM itself, as it processes inputs from various engine and charging system components. Regular inspections and maintenance of the electrical system can help identify these issues before they escalate, ensuring that the vehicle remains in optimal working condition. When DTC P1549 is triggered, several symptoms may manifest. The most common indication is the battery warning light illuminating on the dashboard, alerting the driver that there's an issue with the charging system. Additionally, you may experience inconsistent behavior from various electrical components, such as dimming or flickering lights, malfunctioning infotainment systems, or erratic operation of power windows. Furthermore, if you are monitoring voltage levels through a multimeter, you may observe readings that are significantly higher than normal, indicating the presence of high voltage from the alternator. These symptoms highlight the urgent need to diagnose the issue accurately to prevent battery failure or electrical system damage, maintaining the vehicle's reliability. The first step in troubleshooting DTC P1549 is to start the engine. This action initiates the alternator's function of generating electrical power, allowing you to assess its output under operational conditions. It's essential to ensure that the engine is at idle for a stable reading. Once the engine is running, the next part of this step involves preparing to check the vehicle under specific conditions. Before proceeding further, make sure to turn off various electrical loads, such as the air conditioning system and headlights, as well as the rear window defogger. This minimizes the load on the alternator during your inspection, allowing you to obtain accurate voltage readings. This preparation is crucial for identifying whether the alternator is indeed generating high voltage, as it isolates the alternator's output in a controlled environment. The second troubleshooting step is to hold the engine speed at 3,000 revolutions per minute (RPM) without load, ensuring the vehicle is in either park or neutral. This process simulates typical operating conditions for the alternator under no load, allowing for accurate voltage measurement. It is vital to maintain this speed for 1 minute, as it provides a stable environment for the PCM to monitor alternator output. Observing this step within specified settings not only helps in verifying the voltage, but also reinforces whether the existing conditions lead to the high voltage problem contributing to the DTC. Proper execution of this step is essential, as it directly impacts your ability to diagnose the system effectively and ascertain whether the alternator is functioning within the established parameters set by the manufacturer. Once the necessary repairs have been completed, it's time for final repair verification under DTC P1549. Begin by ensuring all connections and components, including the alternator, are securely reassembled and functioning correctly. Revisit the previously established steps, starting the engine again while ensuring that all electrical loads remain off during your test. This will yield a controlled environment to observe for DTC reoccurrence. After confirming that the DTC does not reappear, monitor the vehicle's performance over several drives. This helps ensure that the rectified charging system operates efficiently without any faults. Document any changes or anomalies during this monitoring phase, reinforcing the reliability of the repairs made to prevent further high-voltage incidents in the future. Preventive maintenance is crucial in minimizing the chances of encountering DTC P1549 again. Implementing regular checks on the alternator, including inspecting for signs of wear and tear, can help identify issues before they lead to high-voltage conditions. It's also essential to routinely examine electrical connections and wiring for signs of corrosion or damage, as these can contribute to erroneous voltage readings. Keeping the battery terminals clean and secure will further optimize the entire charging system's performance. Regular vehicle inspections can also include monitoring voltage levels as part of a comprehensive assessment of electrical components. Alongside these steps, keeping an eye on the dashboard warning indicators will provide timely alerts to any developing issues. In conclusion, understanding DTC P1549 is vital for diagnosing issues related to high voltage within the charging system of the Honda CR-V 2023 Plus. The primary component of concern is the alternator, and recognizing the implications of excessive voltage can aid in preventing significant damage to the vehicle's electrical system. By following the outlined diagnostics systematically, you can pinpoint the root cause effectively, whether it be a faulty alternator, wiring problems, or issues with the PCM. It's crucial to remain diligent about preventive maintenance through regular inspections and prompt attention to warning lights. This proactive approach is fundamental for maintaining vehicle performance and ensuring the longevity of its electrical systems. Please like and subscribe to the channel. See you next time.